Okay, good morning class. So at this point we are looking at the paper that you guys have written in your June exam. I think before the video cut out you were concluding question 4.2.7. So the question says show with calculation that the two circles will intersect. Give a reason for your answer. So we established that for the circles to intersect, that the distance between the two centers has to be less than the sum of the radii of the two circles. If the distance between the two centers are equal, then the two circles will touch each other at one point only. If the distance between the radii, the centers of the circle is larger than the sum of the radii, then which means to say the circles are disjoint or the circles does not intersect. Okay. So to work out the centers of the two circles, I call that C1 and that was of course C2. C1 being negative 4 and 3 and C2 being 3 and 5. Work on that into the calculator. Let's just put up a calculator here. That's going to be the square root of open brackets negative 4 minus 3 squared plus open brackets 3 minus 5 squared. Then the answer of root 53. Is that correct? It does not ring a bell. But it's been a while. I hope you guys had a good holiday. The negative 5. Okay. So that's supposed to have been positive. Okay. There we go. That's the value. So that's the square root of 113 or 10 comma. This is the 10,63. Okay, so the radius of the first circle, radius 1 plus the length of radius 2. The radius of the first circle is going to be root of 20. And of the other circle it was? Sorry? 15. Yeah, it is 2 to 5. The square root of 2 to 5, which is 15. So the square root of 20 plus 15 gives us 19, 47. So what does that mean? You see that the sum of the radii is larger than the distance. So you say since the square root of 113 is less than the sum of the radii, which is 19,47, or you can repeat that. Therefore, the circles intersect each other at 2 points. Right? You guys understand? Let's go to the next question. Remember that the question paper and memo can be found in the description box for you. Okay. Question 5. So here we are told that a moth flies in a perfect circle around a candle. It will stay exactly 8 centimeters from the flame. So if you got the flame here, and there we go, the moth is staying exactly, or flying exactly 8 centimeters from that point. Okay? If the candle is located at the point C, which is 4 and minus 3, write down the equation of the path flown by the moth. So what type of shape, or what type of model is being expressed here? A circular model, not so. So it's going to follow the equation of a circle. So x minus a squared plus y minus b squared is equal to r squared. Why this formula, not the other? We know that the center of the circle is not at the origin. Okay, so it's going to be x minus 4 squared plus y minus plus 3 squared is equal to 8 squared, which is simply going to be x minus 4 squared plus y plus 3 squared is equal to 64. If you wanted, you could have multiplied that story out. But at this point, I gave you full marks at that point already. Okay. Let's look at number 5.2. A circle with the following equation: x squared plus 8x cos theta plus y squared plus 10y sine theta is equal to 41 is given. Write the given equation in standard form of x minus a squared plus y minus b squared is equal to r squared. So again, we know that for that thing, we're going to get x squared plus 8x cos theta plus a number plus y squared plus 10y. Let's take this out, write it a bit neater. This is x squared plus 8x cos theta plus a number to complete the square with plus y squared plus 10y sine theta plus a number equals 41 plus the first number, which is that number there, plus the second number, which is this number there. Why do we need to do that? So that we can balance the equation. The number equation here, of course, is going to be b. In this case, what is your b value? It's going to be 8 cos theta times a half, and it must be squared. So 8 times a half is 4. So 4 cos theta squared is going to give you 16 cos squared theta. Okay. Do the same here. What's your b value here? It's of course going to be 10 sine theta. So 10 sine theta times a half, and it needed to be squared. 10 times half, of course, is 5 sine squared theta. Okay, 5 is the square must be on the outside. 5 sine theta all squared, which is 25 sine squared theta, which now gives us x plus 4 cos theta squared plus, for this here, y plus 5 sine theta squared is equal to 41 plus 16 cos squared theta plus 25 sine squared theta. Okay. Any confusion at this point? No? Look at the next question. The next question says determine the maximum length of the radius of the circle for any given value for theta. Leave your answer in survey form. So determine the maximum length of the radius. People, where do you get the radius from? We know that this is r squared. Not so. So that means to say that the radius is going to be the square root of that. Remember, plus minus, but not in this case, because length is never negative. Your radius is never negative. So it's 41 plus 16 cos square theta plus 25 sine square theta. Okay. So importantly here, I'm going to get this to be the same ratio. Okay, the same trig ratio. I'm going to change everything to sine. I'll change cos to cos squared to 1 minus sine squared. So it's the square root of 41 plus 16 into 1 minus sine squared theta plus 25 sine squared theta. Okay. So now it gives me the square root of 41 plus 16. I'm getting rid of that brackets. Minus 16 sine squared theta plus 25 sine squared. Okay. Now 41 plus 16 is 57 minus 9 plus 9, sorry, sine square theta. You all agree with that? Alright. But now, if you look at the only thing that can change here, well, the maximum is dependent on sine of theta. Not so. Because if this is a maximum, then the maximum number times 9 plus 57 will be at the maximum. Can you see that? If you take the smallest value here, which is a minimum, and then the smallest number times 9, which will probably give you 0, and then you're left with the square root of 57. You understand? But the question specifically asks for the maximum. So if you're looking at the sine graph, sine theta graph, that's what the sine graph looks like. Not so. So, and which value is sine theta maximum? At what? At 90 degrees. Not so. Remember that asks you for any value of theta. So theta can be 0, 90, 182. Can be any value between this to infinity and negative infinity. Can you see that? So what is the maximum value of sine theta? 1. And it's occurring at 90 degrees. Can you see that? So if that is 1, then this is simply the square root of 57 plus 9 times 1 squared. And 9 times 1 is 1, plus 57 is 66. So it's simply the square root of 66. Okay, that's your maximum value of odds. Alright, any confusion? Any questions? But let's look at question 6. Question 6.1. We are told that sine theta is equal to 12 over 30. Theta is greater than 90, less than 360. With the aid of a diagram, without the use of a calculator, determine the value of sine 2 theta. So, if we go with that then, with this information, sine is positive. It's positive in quadrant 1 and 2. It's greater than 90, less than 360. 2, 3, 4. So it has to be in quadrant 2. So there we go. Sine is opposite over hypotenuse. So the opposite is 12, hypotenuse is 13. I apply Pythagoras. I get 13 squared is equal to 12 squared plus your adjacent side squared. So it's going to be 169 minus 144 is 25. So my adjacent side squared, the square root thereof is going to be plus minus 5. But because this is on the negative part of your x-axis, it's going to be negative 5. Okay. So sine 2 theta is equal to, can be written as you can see this angle here is theta and not 2 theta. So I'll have to convert sine 2 theta to its equivalent, which is, in terms of theta, it's going to be 2 sine theta cos theta. So it's going to be 2. Sine is opposite of hypotenuse, so it's 12 over 13. Cos is adjacent of hypotenuse, negative 5 over 13. So it gives you 10 is negative 240 over 169. Negative 120. So that I got 10 there in my head, but now I got 240. So 10 times 12 is 120. Okay, sorry about that. Let's go to the next question. 6.2. 6.2, we are told simplify without the use of a calculator. Okay, so firstly, the reduction comes into play here. So it's all stations to Claremont. That is 180 degrees. So 360 minus theta takes you to quadrant 4. 360 minus theta is negative sine theta. Sine is negative in that quadrant. Times. Now negative 360, I just add 360 to it. I'm just left with theta. So that is just cos of theta there. Minus theta is in your fourth quadrant, where we don't see it like that. We add 360, so it becomes 360 minus theta. Again takes you to quadrant 4. is negative sine theta over 90 plus. 90 plus takes you in quadrant 2. Cos is negative, although it changes to sine, which is positive in that quadrant. But the negative 6, 180 plus takes to quadrant 4. Tan can be written as, and quadrant 4 tan is positive, so tan is tan. So 1, 2, 3 negatives, the ultimate answer is negative. So I'm not worried about the sign anymore. Sine theta cancels sine theta. So now what we are left with is cos theta times sine theta over tan. And tan is the same as, this line here means what? Divide. Divided by tan. Tan is the same as sine over cos. Okay, natural code is over 1. So it becomes negative cos theta times sine theta over 1 times, and the tumbling times the same. So it becomes cos theta over sine theta. Okay, so what happens now? Sines cancels. Leave you with negative cos squared theta. Okay. Any questions? .3, the question says prove that sine alpha plus beta times sine alpha minus beta is equal to that story. Okay, I know that expansion is easier than reduction. Okay, so I would go with expansion first. So I'm going to go with the left hand side. I might be needing both sides. But sine the alpha plus beta follows the formula sine alpha cos beta, sine alpha cos beta, same sign, cos alpha sine beta. Okay. And because they are written next to each other with no sign, it means multiplication. So it's going to be, for sine alpha minus beta is going to be sine alpha cos beta, same sign, cos alpha sine beta. So of course that is not what we have there. So I multiply this out to get rid of the bracket. As you can see, it's a conjugate pair. So it's sine squared alpha cos squared beta minus cos squared alpha cos squared beta. Still not what I have there. But what do you notice then? You don't have, sorry, as we sine squared beta. What you should notice here is that I got sine alpha, sine beta. So what do you notice? You only have sines. So in other words, we must get rid of the causes. So I'm going to replace that and that with something different. So I got sine alpha, sine squared alpha. What can cos squared beta be written as? 1 minus sine squared beta minus sine squared beta. What can cos squared alpha be written as? 1 minus sine squared alpha. So all I do is I add the bracket here. And now gives me sine squared alpha minus sine squared alpha sine squared beta minus sine squared beta plus sine squared alpha sine squared beta. Okay. So what happens is this cancels in. Same size, different signs. So I'm left with sine squared alpha minus sine squared beta. Have I proven what they asked me to prove? No. So what can be applied here? Difference between two squares. So now it gives me sine alpha plus sine beta into sine alpha minus sine beta, which is equal to that. Okay. Any questions here? 6.4. Determine the general solution to. We got 2 minus sine x equals cos squared x plus 7 sine squared x. So for us to, as you can see, what we have here is squares. And for this one here, we only have a sine. So in other words, I need to change the cos to sine. So we can have sines only in the equation. Why do I want sines only? So that they can factorize. That's the idea. Okay. So what I'm going to do is I'm going to change the cos. Alright, so the cos can be written as 1 minus sine squared x plus 7 sine squared x. So what I'm seeing here is a trinomial already being formed. So take everything to the right hand side, so 0 is equal to, that gives me 6 sine squared x plus sine x minus 2. So minus 1. So that will become 1 minus 2, which is minus 2. Okay, what you should be seeing there is a trinomial in standard form. For those of you who don't see it, you write it in that form. I replace sine with x, so 6x squared plus x minus 1. So that factorizes into 3x and 2x, 1 and 1. That's going to give you plus minus. See, that's the equation. Okay, which gives me an x value of a third, or x is equal to minus 1. Otherwise, you could have used the quadratic formula, you could have completed the square, or you can use that silver calculator there. Okay. So we know that x was replaced with, or sine was replaced with x. So sine x is equal to a third, or sine x is equal to negative a half. Okay. Remember the question was for the general solution. So where is sine x? So you use my reference angle here. So arc sine of a third, arc sine of a third gives me 19,47 degrees. The question that should come to mind is which quadrant is sine? Positive. 1 and 2. So quadrant 1. X is equal to 19,47 plus k times 360. Or quadrant 2. I do get quadrant 2, so x is equal to 180 minus 90,47 plus k times 360. There's 180 minus that answer, which is 160,53 plus k times 360. Okay. On the other hand, we'll work out my reference angle here. We know that's coming from a special angle, so we'll give you an angle of 60 degrees. Question that comes to mind in which quadrant is sine? Negative. Quadrant 3 and 4. How do we get into quadrant 3? 180 plus 60 plus k times 360, which gives me 240 degrees plus k times 360. Or quadrant 4. How do you get in quadrant 4? 360 minus 60 plus k times 360, give you an answer 300 plus k times 360. K is an element of integers. Okay. So that gets you 6 marks. Okay. 6.5. We are told that if sine of 20 degrees is equal to a, find the expression in terms of a. Find the expressions in terms of a. So firstly, I conclude the triangle. Okay. That's 90. That is 20. Sine stands for opposite of hypotenuse. The opposite, of course, is 8. Hypotenuse is 1. I apply Pythagoras, I get 1 minus h. If I do sum of triangles, this complementary angle here, of course, going to be 70 degrees. Okay. It's a complement of 20. Or we can go some of that. So let's look at the first one. The question says, now as you can see, there's no 20 degrees there, no 70. So it's either we link it to 20 or we link it to 70. But we know that 35 is the half of 70. Also we know that 1 minus 2 sine squared alpha is also equal to cos 2 alpha. The alpha angle in this case is 35. So this is the same as saying cos 2 times 35, which is cos of 70. Cos of 70 is the adjacent of hypotenuse. So it's a over 1, which is a, or we could have written this as sine of 20, which is a. Okay. 6.5.2, cos of 50. So again, there's no 50 degree here. So I must link 20 or 70 to 50. I can say 20 minus 70 is 50. Not so. Or, we could have said 30 plus 20 is 50. Not so? Or there's always, I could have done it. So what I do is I say, okay, this is the same as saying cos 70 minus 20. Okay? Let's go with the cos expansion. So it's cos 70 cos 20. Opposite sign, sine 70, sine 20. Okay, so that gives me cos of 70 is cos is adjacent of hypotenuse. It's a. Cos of 20, the adjacent of hypotenuse. So it's the square root of 1 minus a squared plus. Sine of 70, sine is opposite of hypotenuse. So it's the square root of 1 minus a squared times sine of 20, opposite of hypotenuse, so it's a. So as you can see, it's going to be the same. Not so. So in other words, it's going to be 2a square root 1 minus a squared. Okay. I've done both methods there. I've also went with sine of 40. Cos of 50 is also the sine of 40, and I went with a double angle here. So if you had applied that route, you can just check it out on the memory. Okay. So that brings us to the end of question 6. Now we go to question 7. We are told that in the diagram below, if of x is equal to a cos x, will become a cos x plus b, whilst g of x is equal to c sine x, where x is an element of negative 1 and equal to 80, which means to say that is the domain in which the graph is drawn in. So here we know that your a is the amplitude of the cos graph, and b is the shift forward or back on the cos graph, and c is again only the amplitude of the sine graph. The question says write down the values of a, b, and c. So as we see the amplitude of the cos graph, which graph is the cos? Okay, so if we look at the G graph is the sine graph. What do you notice here? The graph is going down then up. Okay, which means to say this is negative. It's going all the way to 2. Negative 2. So your C value, of course, is negative 2. Okay? Then, if we look at the cos graph, the cos graph's amplitude is 1. Okay, you see that? So the normal cos graph starts here to 90 to 180. That's what the normal cos graph looks like. But this graph is starting at 45. So this graph has moved 45 degrees forward. Can you see that? This is would have been normally there. And then of course this is the normal cos graph. But what do you notice about this? That graph moved 45 degrees. That point has moved 45 degrees that way as well. Can you see that? all these points move 45 degrees forward. Which means to say, your A value of course is 1, and the graph moves 45 degrees forward, so it's minus 45. Okay, so A is 1, as the amplitude is 1 there, and of course your C value, or your B value in this case, is going to be minus 45 degrees. As we know, if it's negative, it moves forward 45, it's positive, it will move back 45. Okay. Let's go to the next question. The next question says, write down the range of g of x minus 1. People, what's the range of g of x as it stands? G of x is between negative 2 and 1 and 2. Can you see that? The range is all possible y values. So the range is from negative 2 to 2. But what happens to this graph? Moves 1 unit down. So from negative 2, it will move to negative 3. So y must be greater or equal to negative 3. But they send it equal to, if that move 1 unit down, goes to 1. Okay. Let's go to the next question. What was the G graph? Yeah. The next question says, write down the value of x for which f of x times g of x 7.3, f of x times g of x has to be greater than or equal to 0 in the interval from negative 180 to 0. So only from there to there. We don't want you to go further than that on answering this question. So people, when do we multiply two numbers and the result is positive, greater than 0? Is when both is positive or both graphs is negative. So looking here, is both graphs positive or negative here? No. One is positive, which means to say it's above this line here. One is positive and one is negative. Positive, negative. Till which point? Till 45. What do you notice from 45 to 0? Both is positive. Can you see that? Although both, at this point both is negative here. Can you see that? But did I ask us with regards to this graph here? No. Okay. So in other words, where is that the case? For x is greater than negative 45, but less than 0. But what do you notice? He has an equal sign as well. It can be equal at negative 45 and it can be equal at 0 as well. Okay. What else do we notice? We must see where the graph is also equal to 0 in that given domain. So as you can see here, that could also be included in the solution. Why? Because at negative 180 degrees, it's equal to 0 there by multiplying. Okay? So I must say, or x is also equal to negative 1. Alright. Let's go to question 8. So here we are told that in the diagram O is the center of the circle. O is the center of the circle, R is 2. OR is R, lowercase r there, and so is OS of course. S1 is theta. Okay, there's mark theta. And angle P is double S1. Angle P is double S1. So if S1 is theta, then angle P has to be 2 theta. Not so. Why? Because if S1 is theta and the angle P is twice that angle, so it has to be 2 theta. First question. Determine the size of ROS, so ROS, in terms of theta, giving you reasons. People, this is the center of the circle. Okay? So R, if this is the center of the circle, we know there's a relationship that exists between angle ROS and angle Q1. Why? Angle at center is twice angle at circumference. Not so. But I can work out Q1. Q1 is actually equal to, angle Q1 is equal to angle theta plus 2 theta, which is 3 theta. Why? We don't have to write the reason here. Exterior angle of triangle. And this is triangle PQ. Again, you don't have to write this. This is not Euclidean geometry. Unless the question says with reason. Oh, give you reason. Okay, so now I understand. Okay. So this of course is 3 theta. So now we can say that ROS is equal to double that, which is 6 theta. Why? Angle at center is equal to 2 times angle at circumference. Okay. Let's go with 8.2. Question 8.2, we are asked to prove that for 6 marks or 4 marks. Question is in total 6 marks. This question says now that prove that R is equal to 1 over 3 theta. So what you notice here is that you can either use the cos rule or the sine rule. Why? Because we can actually go and work out what R2 is and what S3 is. Okay, in the memo I've worked out both ways. So I'm just going to go straight into the cos rule. We know that OS is equal to R. Is needed reason required here? No. As the question says here, give me reasons for 8.1. No reason required for 8.2. But the reason why that is R is because of the fact that it's your radius. Radius, okay, or radii. So there's also R. So we have 2 lengths and included angle. So the cos rule says 2 squared is equal to R squared plus R squared minus 2R times R cos of 6 theta. Okay. So of course it's going to be 4 here. So it's going to be 2R squared minus 2R squared. Now cos of 6 theta. Remember, this can be written as cos 2 theta times 2 times 3 theta. Why do I write it like that? Because that is going to be your cos 2 alpha is equal to the sine here. Definitely use the one dealing with sine. So it's 1 minus 2 sine squared alpha. So in this case, if you got cos, just write it here, cos 2 times 3 theta, I'm going to use this expansion here. So it's going to be 2R squared minus 2R squared into 1 minus 2 sine squared 3 theta. Okay, so that is 4 here. Let's carry on. Get rid of the bracket now. So it's going to be 4 equals 2R squared minus 2R squared plus 4R squared sine squared 3 theta. That of course cancels. Now to get R on its own, I'm going to divide both sides. Remember, this is not R here. To get R squared on its own, I'm going to divide both sides by 4 sine squared 3 theta. 4 cosine squared 3 theta. So of course that cancels. So r squared is equal to, again that cancels, 1 over sine squared 3 theta. Do we have what is asked to prove? No. You must not square it. Why did you square it? What must I not forget? Plus minus. But this is referring to length. So r has to be positive. So r is equal to 1 over sine 3 theta. And there we have just proven what they asked us to prove. Remember people, in our proof, you can't use the fact that r is 1 over 3 theta. You must end off with that. Okay. Is there any confusion? All right. Question 9. Give a reason for all your statements. You are given that PQRS with center, given circle PQRS with center O, prove the theorem that states that P plus R is 180. Which theorem is this? Opposite angles of side equality. The link to the theorem can be found in the description box below. Okay. Question 9.2. In question 9.2 we are told that 9.2 we are told that the line ABC is a tangent to circle at B. People, if there's a tangent to the circle at B, then we know that this angle here is equal to that angle. Why? Tan cot here. Likewise, this angle here is going to be 45 degrees, and so on and so on. Okay. So x is actually equal to y. Then we are told that ADE is a tangent to circle at D. People, if that's the case, what do we know? We know that BDA is also equal to angle Y. Tan cot theorem. We also know that this length is equal to that length Y. Tangents from common point A. So isosceles triangle is being formed there. So this is also x. Then we are told that GB is equal to GH. People, if these lengths are equal, what do we know? We know that GDH is also 45 degrees. Why? Equal chords obtains equal angles on the same side. Okay. It is further given that we got x, y, and z. Alright. Let's go. With all that information in mind, let's pull this over. All that information in mind, let's see what the first question is. Show that x is 56 degrees. How many marks is on that? Probably 4, 3. X is 56 degrees. Okay. So firstly we know this is going to be x here as well. Not so? So we first going to say that BA is equal to AD. Why? Tangent from common point. Okay. So that is equal. Now 2x plus 68 is equal to 180. Why? Sum of triangles. This triangle D AB. So x is equal to 180 minus 68. Divide by 2. give you 56 degrees. Okay. The next question, let's go through this one first before we go for assembly. Write down with reason the value of y. That's simple. Y is equal to 56y tan quotient. Okay. Calculate the value of z. So now z is complementary to c. Sorry, supplementary to C, B, G, B, D. Why? Opposite angles of cyclic chord. Not so. But I can actually work out this angle here. So let's go. We go G, B, D is equal to 180 minus 45 minus 56 degrees. Why? Sum of triangles, and it's triangle G, B, D. Again, you don't have to know the triangle you're working in, so it's 180 minus 56 minus 45, which is 79 degrees then. So Z is equal to 180 minus 79, which is 101. Why? Opposite angles of cyclic chord.